we have the same laws of exponents apply to nth roots, which we've just defined. And we had a certain number of rules of exponents which applied when we defined the exponents for integers, and now the same rules apply for nth roots. However, they don't make sense, all of them don't make sense yet, because we haven't defined a to the x, where x is a general rational number. So we haven't defined a to the m over n yet, so there are only a few rules which we can look at right now. So rule 4 said that a times b to the n, or x, is a to the x times b to the x. And this still works when our power is an nth root, or 1 over n. And so what we're saying is a times b to the 1 over n, according to our definition, is a to the 1 over n times b to the 1 over n. And you can see why that might be true in this case. If a is 27 and b is 8, then 27 times 8 to the 1 over 3, we're saying that that's 27 to the 1 over 3 times 8 to the 1 over 3, and that's equal to 3 times 2, which is 6, and you should check that when you multiply 27 times 8, that in fact that's equal to 6 cubed. Another rule which generalizes is that the nth root of a over b is the nth root of a over the nth root of b. Our a over b to the 1 over n is a to the 1 over n over b to the 1 over n. And this comes from reversing the previous rule using our definition of a to the 1 over n. So if we take 27 over 8 to the 1 over 3, that should be equal to 27 to the 1 over 3 over 8 to the 1 over 3, and that's equal to 3 over 2, and you should check that 3 over 2 is indeed the cubed root of 27 over 8 by cubing 3 over 2. You should find that that's equal to 27 over 8. The general proof is similar, except instead of a particular number, you use a over b and 1 over n here. And if we want to generalize rule 3 above, which says a to the x all raised to the power of y is a to the x times y, then what we get is that the nth root of a, if I apply the mth root to that, it's the same as applying the m times nth root to a. In other words, a to the 1 over n to the power of 1 over m is a to the product of those two powers, 1 over m times n. So what I'm saying is that if I apply the cubed root to the square root of 64, it's the same as raising 64 to the power of 1 over 6, or the 6th root of 64. And you can check that this is true. The square root of 64 is 8. Take its cubed root, I get 2. And then 2 to the 6 is 64, so 2 is the 6th root of 64. And again, the general proof is very similar. Instead of using 64, you use a, and instead of using specific powers, you use m and n. Now, in general, the nth root of a to the n is a itself is n if n is odd. So, for example, minus 3 to the 3, if I take the cubed root of that, I get minus 3 again. However, if I take the nth root of a to the n when n is even, I get the absolute value of a. And you can see why this is true. if I take n equals 2 here, when I square minus 3, I get 9. And then when I take the square root of 9, I get a positive number. I get the positive number 3, which is the absolute value of the original number a equal to minus 3. Okay, you might want to take a shot at working these out before you see the solutions. So if you pause the video for a little while and then switch it on, you can see how these are done. Okay, so I'm going to try to simplify the cube root of 27 times x cubed times y to the 6. And so using these rules, by rule number 1 there, I can break this up into the cube root of 27 times the cube root of x cubed times the cube root of x to the 6. And now the cube root of 27 I know is 3, so I can write that down because 3 cubed is 27. And the cube root of x cubed, well, according to rule 4, that's equal to x itself. And now the cube root of x to the 6 is the cube root of x squared to the 3. And again, I can use rule number 4. So this is equal to 3 times x squared. And now that's 3 times x cubed, and that's a simplification of what I was given. Let me try b, which is the square root of 500 plus the square root of 18. Now I'm going to factor this into something more manageable, something that I know square roots of. So this is the square root of 5 times the square root of 100. So this is 5 times 100, and this is using rule number 1. Plus, this is equal to 2 times 9. So it's the square root of 2 times 9, which is the square root of 2 times the square root of 9. And now I know that the square root of 100 is 10. So that's the square root of 5 times 10 plus the square root of 2 times 3. And that's about as simple as I can make this. The square root of 5 and the square root of 2 are special numbers, they're irrational numbers, and their decimal expansion goes on forever. So this is as simple as it gets.